Today we're going to take a look at a program called Geogebra, which is available both in an online version, a version for your tablet or phone, as well as a version for a desktop computer. We're going to look at the online version since that's the one that you can access from any device at any time. So to start, you go to www.geogebra.org and you'll be brought to a page actually that looks like this. When you get here, the first thing you're going to do is you're going to sign in, and you're going to sign in using your school Google account. So we'll click here for Google and type, and in this case, it'll bring you in if you've already created an account. As I have, it will bring you up and show you any materials that you've created. Otherwise, it'll give you a screen that looks like this, but it won't have any already created materials. Once here, you're going to click Geogebra, and that'll take you back to this page, at which point you click Graphing Calculator. So we are going to focus on Geogebra as a tool for algebra. It obviously, given the name, is also useful for geometry, and in fact, it combines the two very nicely. When you open the Geogebra Graphing Calculator, this is what you get. So let me just quickly look at the pieces here. So the left side here is the algebra panel, and any objects that you create in Geogebra will be listed here, as we will shortly see. This right here is the input box, and this is where you would type in what you need to create a new Geogebra object. This here, this grid, is what is known as the graphics view, and basically anything you create that can be shown in a grid, Geogebra will show you here. Again, we'll take a look at that in 1 second. So let's click into this input box, and we don't need this keyboard here. If you were working with a tablet that did not have a keyboard, then you might need this, but we don't need it, so we're going to close it to give ourselves a larger grid. So let's say we want to create a point. So I could just type in the coordinates for a point using parentheses, and as you can see, Geogebra creates a point, labels it A, and then lists it up here in the algebra view. Now, what we have here, it gives us the name of the item it created. When you don't specify a name for a point, Geogebra will, by default, give it the name of the next available capital letter. So this little circle right here, as you can see, when we click this, it toggles that point on and off. It doesn't delete it, but when we click here, it hides that point so it doesn't show up in the graphics view over here. We also, if we click in here, we could delete this object, in which case we're now back to where we started. So let's say we're going to call this A equals, let's say 3, 4. Okay, one thing you'll notice is there are these icons up here. The most important icon is this arrow icon. When you click on it and select Move, it allows you to click on objects inside this graphics view and move them around. And as you do, you'll see that Geogebra will update the coordinates inside the algebra view over here. So now we've dragged that point to 4, 2. So we're going to create a second point. Let's say B equals 5, 1. Okay, so now we have 2 points. So now let's suppose that we wanted to think about creating an equation of a line that would pass through these 2 points. Well, let's start slowly. We'll say, well, what if we create a line that has the equation y is equal to 2x plus 1? We'll type in literally y equals 2x plus 1. Geogebra creates that line and then shows it here in the graphics view. You'll notice that if we click on this, we can drag it and Geogebra will change the equation for the line. Notice that in this case, the only thing it can change is the slope, is the y-intercept, not the slope. So the slope will remain unchanged. Okay, so now let's do something else. Suppose we say we're going to create we're going to call a variable, and we're going to call it A. And type A is equal to x, there's parentheses A. And notice that Geogebra assigned that variable A a value of 4. take a look what happens to that variable value as we drag this point A around. So right now it has a value of 3, a value of 4, still a value of 4. So what that variable represents is the x-coordinate of this point A. So now suppose we wanted to create a variable that contains the y-coordinate. Well, we could do this. B is equal to y of A. So it's the same idea except A instead of x. Now let's say we want to do the same thing for point B, so we say C is equal to x of B, and just to show you that how GeoGebra does naming, we won't give this a name, we'll just say y of B, and we'll see that GeoGebra creates another variable that gives it the name lowercase d. So when you're creating numerical variables, GeoGebra will name them by default with lowercase letters starting with A and then just assigning them the next letter in the alphabet that's available. Okay, so we know that when we're looking at the slope of a line, let's say we want to think about the line that would pass through points A and B. Well, we can see right now that the change in y going from B to A is 2, or I should say from A to B, and the change from A to B, the x, is 3. So if we wanted to actually create an expression to reflect that, well, here's what we would do. We would say, let's call this variable m. If we don't give it that name, then GeoGebra will just call it e by default. But we want it to be the slope, so we want to use the variable m. So we could say that m is equal to the change in y from B to A, so that would be d minus b, divided by the change in x, which would be c minus a. Okay, so m now has the value 2/3, and you could see that if we move this point around, the value of m is going to change. All right, so let's hide this line for now, and let's say we would now type in y is equal to, we'll use our variable, because wherever you use a number in GeoGebra, you could replace it with a numerical variable. So we're going to replace the number that we ordinarily use for the coefficient with the variable m, and then we'll say y is equal to mx, and we see now that we have a line that is going to be parallel to the line that goes through A and B, but unless we line up A and B exactly right, that line will not actually pass through A and B. Now it does, but what we need to do is figure out how can we make sure this line has the required y-intercept. So right now we're going to go to our point slope form, which we say works like this: y minus the y coordinate of one of the points on the line we want to create. So let's say we can refer to that as d is equal to our slope times x minus our x coordinate of that same point. So in this case, we chose D, and so that means we're talking about point B, so we need to choose C. And now, as you can see, we have another line. I'm going to hide this line. And now this line does pass through the points A and B, because we've created a line that no matter where A and B are, it's going to draw the line that passes through them. We'll actually look at one exception to that in a minute. One thing you'll notice is that instead of putting this line in the y equals mx plus b form, GeoGebra by default put it into the standard form, or it's actually not exactly what we think of as a standard form, but a different form. When we want to make sure that GeoGebra uses the slope intercept form of the equation, here's what we can do. We click on this little star thing here, and then we click into our line, which is down here, and you'll see that on the right, GeoGebra brings up a whole lot of options, and what we want to do is click on algebra, and it's going to give us this box here, equation, and when you click that, you'll see that there are a number of different forms that we can choose. We're going to choose y equals mx plus b, and you can see that when we do that, the equation is now changed to y is equal to 0.33x plus 2.67. Now we can close this. So as you can see, we have created a line, and we defined it in such a way that that line will always pass through our 2 points A and B. And so right now we've created a number of objects in GeoGebra. And we've created 2 points, which are listed here with their coordinates. We've created 1, 2, 3, 4, 5 numerical variables that represent the x value of A, the y value of A, the x value of B, the y value of B. And then we created M, which actually uses these other variables in an expression to generate the slope. We created a line here, which we're actually not showing at the moment, so we can delete that line, just like we can also delete this line. And now we have our 2 points, our 5 numerical variables, and then a line that uses these variables in the equation. So we've created a line, and no matter what happens as we move A and B, we're going to see that it creates a line, but notice what happens right here. When A and B are aligned vertically, notice what happened to our M value. And the reason for that is that at this point, C and A, since they represent the x coordinates of these 2 points, C and A are equal. So this C minus A has a value of 0, which means that, well, according to GeoGebra, the slope of this line is infinite, and it doesn't define the line any longer. So GeoGebra will not, at least by this method, create a line that is perfectly vertical. But as soon as you move A, even just a little bit off of the same vertical line as B, we'll have a line again. And of course, when we have a horizontal line, you can see that in this case, the y values are the same for the 2 points. So now D minus B is equal to 0. C minus A is not equal to 0, so we get a value of 0 and a line that has a slope of 0, so it just has the equation y is equal to 2.